As you look at my system here, for those that have been following, you might notice I've added something new. I now have a small LCD down here. I had, in the last video, done some work with the VGA, so I've got this VGA circuit I'm using, and that's working pretty well. But I thought it might also be nice that if I really did want to make as small of a form factor of a single board computer as possible, that circuitry maybe is too much. You know, I do have a version of this. Hopefully that'll be up and running. That's half the size, but that's still a lot of space. Plus, then you hook up to an external VGA monitor. So I thought maybe an alternative, and I would have to still decide, do I want to keep this LCD over here or not, or just go with a single LCD that looks like this, that is a higher resolution. It's about 480, not about, it is 480 by 320. So this resolution, it has twice as many pixels as I'm outputting to my VGA, but it's also very small. So that is also maybe a challenge, and it's really hard in these types of videos to record that effectively. But I'll do my best here, and let me first just show you what I have going on. So I have this LCD. It's connected to one of my versatile interface adapters that's connected to my 65265. And I'll go into more detail about the connectivity here in a bit, but I want to just kind of turn this on and show you what am I doing so far. Now, when I first turn the system on, you know, it does work through getting my VGA memory cleared and outputting a test screen and then a little ship that flies across it. And of course, I have my little 2-line LCD over here that also gets initialized and is ready for input. But after that, I then initialize this LCD. And so from my assembly code, I am basically clearing the screen, writing all black to it, and then I put up some color bars just to test that I can draw those color bars fine, and then I animate that little ship across the screen. Now that's not using any helper libraries. You know, there's no Adafruit graphics library here or anything like that. This is all just being done right from assembly code, and I'll show you that code and show you what I have started. And I'll also put out the asterisk here that I could spend 100 or 1,000 hours just writing graphics routines. There's just so much you could do with this. But my goal right now is to get per pixel control so that I can pixel by pixel do whatever I want on this screen. And that's really how it's designed. It doesn't come with any, you know, fancy fonts or other things like that. It doesn't have native functionality for drawing shapes. You know, that's all stuff that, like on the Arduinos, I think a lot of the vendors use the Adafruit graphics library for all of that type of work. But I want to make sure I can get pixel level, and then I can treat this just like my VGA. I mean, it's different, but it's similar, right? It's pixel by pixel control. So if I want to draw a box, I have to calculate where the box is going to draw and draw the individual pixels to do that. If I want to do a font, I'm going to have to store font data in my ROM, my external flash, and then process that and draw out in the right position whatever pixel should be on for whatever characters I want to show. But let me turn this on. And on my screen, I will capture my VGA output. That takes a second, so I'm just going to hit reset and let this boot one more time. So I pause. Okay, there's my VGA coming up. Ship flies across, and then I transition to this screen, and you can see I clear it. And then I write a red bar, a green bar, blue bar, white bar, and then that little ship flies. Same little ship, same ship out of my ROM data. I have it fly across the screen here. I'm going to hit reset one more time just to give you a chance to focus on this LCD here as it comes up. But basically, I have to initialize the screen, clear it, put my color bars, and put my little animated sprite. And the little animated sprite goes across just fine. Now the camera is not going to pick that up well, I know that. But I would also comment that even if it does pick it up in an okay way, you'll notice the colors on that sprite aren't exactly the same as on my VGA. And I'll show you why here as I get into this. But it has to do with a different total number of bits available for color, and I did not go through the effort of trying to map or make a new sprite with the 16-bit color instead of 8-bit. So what does it take to get this little screen working is a question. So let me pull up a web page here and talk about the screen that I ordered first of all. So this is the screen that I ordered. It's a do-it-yourselfables, DIY-ables. I had not heard of this company before, but this is a screen that ultimately I selected as the one I want to work with. The things that got me to this is I wanted something without the touch. I don't need any touch interface. I'm not planning on doing any of that right now. Maybe I'll do touch later, but this is a non-touch interface. It's a reasonable resolution, 320 by 480. Again, my video card is basically half of that resolution. So 2 of my video cards, their output would fit on a single one of these screens. But this is very small, harder for me to see, harder for the camera to catch it, things like that. But other things that caught my attention is that it is an 8-bit parallel interface. I didn't want to use I2C. I didn't want to use SPI. I didn't want to have to actually put it on top of an Arduino. What you're seeing over here, this is just the raw LCD, which is this right here. And that's all it is. It's this LCD, and this is what the back of it looks like. I'm not using anything underneath it, and I'm connecting from these pins directly into my breadboard over here to one of my versatile interface adapters. So then that gives me a board, and they say, okay, Arduino board's not included, and really they've got this, positioned to work with Arduinos and other types of microcontrollers like that. And I think they have a supported list down here, if you want to look through that list of what do they say is already tested and fully supported. But I'm not doing any of that. I'm just going to take this board and I am going to connect it up to my system. Now, something else that kind of caught my attention with this is it uses a chip here that I think has plenty of documentation. There's a really good data sheet for it. It's this ILI9486. And so I have the documentation for that, and I have that pulled up over here. So it's over 200 pages. That's wonderful that there's documentation I can refer to. They do also have some sample code. So, they talk about a library, but they have some stuff out on GitHub, some code that basically if you're using an Arduino, you could use to get going. Now, of course, I can't load that, or I'm not set up to load that type of code onto my 265. So I had to, or I did, approach it from assembly code from scratch. Now, when I look at this, I want to kind of pay attention to what do I have for inputs. I guess one other benefit of this is it's 5 volt capable, so it's not 3 volt. It can take 3 or it can take 5 volt. You can see there's a little voltage regulator here. So I'm feeding it 5 volt, and right now this is just tapping into my breadboard power rail, so not a good spot for power. And I did run into, as I was going through this, in a previous video I mentioned my video card wasn't getting sufficient power. Now I was finding that these breadboards were not getting good power contact with a single pair. So I ran basically a new, shorter, better connection for power as part of this process. But I'm getting power there, and then there are 8 data bits that I'm going to use. So right up here, I can go from data 0, 1, and then 2 through 7, so my 8 data bits. I'm not going to use these bits over here, more for SPI. I'm not going to use SPI. I want to do a parallel type of bus interface, an 8-bit interface. And then there's a bunch of control lines down here, and maybe can I zoom into this? Perfect. So the control lines that I'm going to work with, I have a read, a write. They call it RS, but it's whether I'm doing a command or data. Then there's a chip select, and then there's a reset. And I'll talk a little bit more about those here coming up. So what I've done is I've gone over to my VIA, and I just documented this in my schematic. So if I go to that VIA, I'm taking 8 of the data lines, the 8 data lines, and running them to one of the banks. So it's this A bank, or port A. And then I'm taking the control lines, which you can see here are those 5, and I'm running those to 5 pins of port B. And I've got 3 pins open that I probably just won't use, or I'll find a use for them later. So those are the, what do we have then, 13 lines that I'm connecting from my VIA to the LCD, and then the LCD is also getting power off the breadboard. And that is all of the connections I'm using on this. Now with that, maybe then I can go over and start showing you what does the code start to look like to actually get one of these up and running. And here is my current code, and I'm going to scroll up. A lot of the stuff, last video I actually spent a whole bunch of time in the assembly, so I'm not going to spend much time in that right now, but I'm just going to point out in this latest version what some of the changes are. First and foremost, I came in and I added some reservations for some memory, specifically to work with this LCD. And some of this annoys me when I don't have them all the same, but I set aside some memory here for some variables, and you can kind of take a look at that. This is the list of things that I'm using throughout the code. So when I post this, if you want to, implement this, these are the ones that I had set up. I don't know if I'm still using all of them. Some of these I might have later decided not to use, but these are the ones I set up for reservations, just for some variables, some space I could work with. And then when I turn on my system, I go through initializing all this stuff, right, that we've been talking about, or I've been going through before. So I initialize the UART and the VIA and the VGA. But now you're going to notice that there are 3 new ones. And I've gone in, and right now they're just called, actually, these were my VGA, sorry. So these are the VGA ones where I clear the VGA screen, I put up the test pattern, I run the animated ship across, I initialize my 2-line LCD on my keyboard. Then here's the new ones that I've come in and added. So I've added an ILI init, and that's probably going to be hard for me to say. I should have come up with a better name. But I tried to put a prefix on all of the stuff I'm doing around this, just ILI. Remember it has this ILI9486 interface chip. So I just shortcutted that and said, okay, ILI is what I'm using. I'm going to call it an init or initialization procedure. I'm going to call a test pattern, which for now just puts up those 4 bars, a red, green, blue, and white. And then I have a little routine that draws that animated ship across the screen. And as a reminder from the last video I mentioned, I've got this animated ship. There is a sprite, software sprite that I have in the ROM data, and I use the same one. So I'm just going to use the exact same data that's already in ROM that I'm using for my VGA output. It's just now I'm going to use it on the LCD. And then for all the LCD work, I made a separate file. So it's just called ILI9486.asm, and that's what I'm going to walk through right now. And just kind of give you the general idea of what does it take to control this LCD from my essentially 65816 code that's running on my 265 board. Now, a couple of things. As I get into this, I'm reading from the VIA port often. I kind of need to read what's currently being put out on the VIA port and change a single bit. And normally in the past, I've always done that with just direct VIA reads. Somewhere along the line, I was doing some troubleshooting, and I ended up setting up a little shadow variable that whatever I write to the port, I store in a shadow variable, and that's actually what I read back, and I'll do my ANDing and ORing, and then write it back to the variable and also out to the port. Doing a little bit of reading, I guess there are some cases, or maybe even with specifically the W65C265S that I'm using, that it is not guaranteed that if you're in output on a port and you read the value of it, that the latched value you get back correctly. So I don't know if that's the case truly or not, but I was running into something that wasn't making sense at the time, and I implemented that. So if you see the shadow, all I'm doing is using a spot in memory to track what did I write out to the VIA most recently. And I think I can strip that out at this point, but it's still in there. So just a note there. This entire module, I'm going to assume 16-bit accumulator and indexer as I get into it, and then I put in the link to both the LCD, that page on DIYables, and then I also put a link to the data sheet. You can find it in a few different spots, but this is the one that I linked in here. And then I just mentioned, okay, this is how I connected it up. So again, I got my VIA port A is connected to all my data pins, and then I take these signals off of port B and connect them to these pins on the back of that screen. And as a reminder to myself more than anything, I just put in and said, okay, I'm going to use VIA 2 and its address is this. I have a port B, port A, a DDR-B, which is a data direction register for port B and port A. Those are things I want to work with, are those right there. And then I set up which bits essentially on port B am I using for these different things. So if I go over to my schematic, the lowest bit is the RD. So RD here just is marking that's the lowest bit. WR is the next, CD, CS, and reset. So these are just little equates to help me remember that and use those friendly names if I want to use them later. So then the fun comes of how do you initialize the screen, and I'm going to jump into just this init and just show you there's quite a bit here to get that screen initialized. Now, I didn't have to invent all that or figure that all out. I did go over to one of the sample libraries for an Arduino and just kind of took a look at the C code that they had there, or C++, whatever it was, and kind of went through that and said, okay, this helps me understand how I need to initialize some of this stuff, because some of the stuff you would not just figure out. You have to set these values specific to what the LCD vendor says they should be set to or recommends. And maybe there are ways you can do it yourself, but this is, as I was reading up on this, some of these values are what does the LCD itself, its specifications, what does it need to be set to? So you need to know a lot about the LCD. And I pulled this off the sample for this specific LCD. So I had some confidence that hopefully those values are good. Let me run through this at a real quick level, fast level here, but I do set up some variables I mentioned before. So I clear those out. I just store Z's. Again, I'm in 16 bits, so this is storing 2 bytes of zeros in each of these. And then I drop into 8-bit accumulator. And I remind myself interrupts are already disabled. I've already initialized the VIA prior to getting to this. That's part of my main assembly, and there's an init VIA that I can go back to. Where is it at? Right here. And it's not crazy complex, but it's just simply saying, okay, disable interrupts on VIA 2, and then set all the pins to output. And then I put some values out on the ports right away. So when I turn on this system, I'm using this little debugger board down here, which is still coming in super handy. So I'm plugged into port A and port B of VIA 2. And it's going to show me what's out there for basically my commands, my control, and what's out there for data. Actually, other way around. This is my data port. This is the control port. I also still have this one over here hooked up to the other VIA, and as I hit keys, it'll show me the ASCII value on that. So that's a 1, 2, 3, 4. So I'm showing the 1, 2, 3, 4 over here. I'm showing the ASCII bit pattern over here, just for the fun of it. No practical purpose right now. But there's a practical purpose. And like when I reset the system, which I just hit the reset button, I initialize and I put out that pattern of every other bit. But as I'm going through the LCD work, I can see what it's doing, which control bits are set, and I can see that the data was running through a lot of stuff and changing quickly because they were dimmer and they were all lit up. But it just shows me the activity that's happening there, which is super helpful. Now, one thing when I turn this on, that data port, until you initialize the LCD far enough, it's also putting out data onto the data line. So that's why I didn't want to have it on my main data bus. That would be a problem because it would cause issues. Maybe there's a way to address that, but until I set a certain pin or a certain configuration on this, I should say, not a pin, it causes problems. And that when I first initialize this, I do put you can see here in my code, a 10101010 in both ports, but you only see it on this one. That's my control port. The data port, it's outputting at the same time, and you don't see it there. Okay, going back over to my screen setup then, I just probably not necessary, but I just do set all the pins to output again, just kind of have it clean in here and say, okay, I'm initializing the screen. I better double check all of my VIA pins are on output. Then I come in here and I have to go through a sequence of things basically to get this up and running. Now, this shadow, remember, that's going to be whatever I'm going to write out to a port B. I just put it into this shadow variable for now. But I need to send out this value to my control port. And the highest 3 bits are not used. And those highest 3 bits, going back to my schematic, are these 3 bits, so I don't care about those. But then I put out a 10011, and what that's doing is saying pull my reset high. Reset is an active low, so don't put it in reset mode. Take CS and CD low, so chip select is an active low, so in other words, enable the device. I'm going to enable the chip select. CD is whether I'm writing a command or I'm going to write data, and I set that to low to start. And then WR and RD are pulses that you'll use, and you want to keep them high. And so right when the system comes up, I want to pull them high, and only when I want to write data to it or I want to read data from it will I pulse these lines, the WR and the RD, whether I'm going to write to it or read from it. And then in the code so far, I'm only writing. I'm not doing any reading back from the LCD. I'm just going to simply write to stuff. So you'll see me toggle the write pin as I go here. So that kind of gets this very quick configuration in here. And then I do a reset. So I say, okay, now reset the screen. And so I have a procedure for that. And that reset procedure comes in here and basically just simply says, load up, whatever I've got out on my control port, and then flip this bit low. That's the reset bit. So if I AND it, that is going to take it to 0. So set it low, store it back out to the port. Then I delay a little bit, and then approximately 30 milliseconds, and then I come back and I flip that back up. So I take it and OR it with the reset bit. I think up here, what I've done up here, I could also use, instead of this AND bit pattern, I could use this AND. So the assembler I'm using, you say dot, not dot, and then whatever definition EQ you have, and that inverts it. But I put that there, but for now I just kind of wanted to see the bit pattern, so I've got that there like that. But that's basically dropped my reset line low, pausing momentarily, bringing it back up, and momentarily is 30 milliseconds roughly, and then it waits 200 milliseconds. Those numbers I can tweak and adjust. I haven't taken time to do that. That's just where I started them off at. So that gets me into where the screen is now reset. So I've toggled the reset. Then I've got to go through a whole series of commands, and again, I did not try to figure this out all on my own. I looked at the example Arduino project, and there's basically this pattern that you'll see. You're gonna write out a command. So I'm going to write out, tell the screen I want to run command 11, and then I'm going to delay, and then I'm going to write out command D0. And then with D0, I need to send it some data. So I'm going to write out some data bytes, and then I'm going to write it a different command and some data bytes, etc. So let me just show you what do I have for write. What does a write command look like? So how do I write a command to this LCD? So the way that this works is I'm going to basically load up my control, and then I need to toggle a bit. So this is a third bit in. And then I store out whatever's on my other port. That's my data port. And I store onto my data port, whatever it is that I want to write for the command. So A has the command. So when I jump to this write command, I'll first load up A with the command I want to write. That's what gets written out here to the port A. But right before that, I have to go to port B, my control port, and tell it I'm doing a write, basically. And actually, this one here, two things. Let me actually clarify. This is not the write signal. This is this command or data. So if it's low, it is command. And when we get to data, it'll be high. And so let's see. This is write a command. This is write a data byte. And you'll see that when I get down to the, what I'm going to write out is I'm bringing in this CD bringing it high. Up here, I'm bringing it low. So if it's low, I'm going to write a command. If it's high, I'm going to write data. And other than that, the A register has either the command I want to put out onto the data bus, or it has the data I want to put out onto the data bus. And so you'll see, these are the same thing down here. And once I do that, then I can turn around and pulse that write signal. And if I jump over to that, it looks like this is, okay, go back out to that control port, bring down the it is this WR signal, so bring it down and then let it come back up, bring it back up. And that's what I'm doing there, is just toggling or pulsing that write. And that's the point at which it's going to read the data that I put on the data bus, the 8 bits there going to the LCD, and that's either going to be treated as a command or as data, depending on how this third bit of my control is set. So these are just little, utility routines that let me say write a command or write data, and then they automatically set the right bits and pulse this write as need be. So then when I get back up to my code up here, it's pretty simple. I just simply say I want to send this command D0, send it. And that D0 requires 3 bytes of supporting information. So here's my first byte of data, send it, second byte, send it, third byte, send it. Now let's go to a different command. And I put in commentary over here just to match, what are these commands doing? So take it out of sleep. So take the system out, or the LCD out of sleep, wait just a little bit there. And then there's a bunch of settings about setting power. And again, I didn't try to read up on these. I simply used the example for this specific LCD and just matched all of that. So it looks like power settings, voltage regulators, things that are driving the actual LCD panel itself, backlighting, whatever it might be. So you can read through the ones that I set here. Again, I pulled those from the sample project, so there's no magic on my part there. I'm just re-implementing that in assembly. There are some things as I go down through this, though, that I did not follow what the sample project had. There's one of these is this memory access control, and I wrote that command, and then I have to write a data byte that goes with it. And here is what that data byte looks like. But there's a whole bunch of settings, like do you want what order of RGB or BGR, and kind of just setting up where the columns are treated versus rows and things like that. But this is important. As I change this, it starts to change orientation of the screen. So if I'm writing and I have this wrong, it might be, instead of starting in the upper left at 00, it's starting in the bottom left or lower right, or it's set up to mirror on the screen. There's a bunch of different settings in here. This was what the sample project was using, was 48. But that did not work for me, and actually this comment is not valid, so I'm going to erase that one. But I ended up using E8. And if you want, pull up the data sheet, look up E8 and binary. You can read through these bits and read through what each of those things do. But this was the right configuration for me to put it basically in a landscape mode and have data start out 00 in the upper left corner where I wanted it. And then there's a pixel format, and I am doing RGB565, so 2 bytes of data. There's also an option to go with 18 bits instead of 16, but 16-bit is still a lot of colors, way more than I need or really care about. So I'm doing 2-byte color, and it's 5 bits of red, 6 bits of green, 5 bits of blue. And this is the data to set to that for that command that tells it I want to do RGB565. And then there's some things that you set to how kind of a frame rate control, and I'm choosing a kind of a moderate frame rate control. There's a then gamma adjustment, and that's command C8, and there's a whole table of stuff here. And again, there's no way I would ever know what to put in there or know how to guess that. That's got to come from the LCD manufacturer. But this was what was in the sample, so I just brought all these values over. It's a 12-byte gamma curve, and it is specific to the LCD panel that you're using, or the LCD panel is optimized. These settings are optimized for that panel. Then I put it in normal display mode. I tell it basically at this point, bring the display on, wait just a little bit, and then I clear it. Now my clear procedure, as I get into, I want to clear it. Now this gets me into where I want to write pixels out to it. There is no built-in function, I don't believe, to just say clear the screen, clear all the RAM. That's something you've got to do manually, pixel by pixel, is write out, black or whatever you want to clear it with. I could be wrong on that. I do need to go back and spend some quality time with the data sheet. And that would be this data sheet over here, 200 pages of fun. But if I do things like, I'll just search for clear and see if it finds anything. And this will probably take a little time, and it comes back, and yeah, there's nothing in here that talks about clear. And I can start to flip into the table of contents, and I'll zoom into this. And when I start getting into things like different commands, just look at the list of commands here. So there's a lot of good stuff here that I need to read up on and maybe learn more about, but I don't see anything about clear the screen, and that's not functionality built into this as I understand it. This is a chip that's just an LCD interface chip. It's not intended to give you all of the draw circles and triangles and squares and clear screens, and here's a font and type of character, things like that. So my clear screen then has to go through all of the pixels and set them. And I'm going to use 16-bit accumulator for this. And the way it works is there is a command you got to send and parameters to send that say set an address window. So within my screen, what chunk of it do I want to work in? You have to tell it the XY start and the XY end. And you have to tell it, set this as the address window I'm going to work in right now. And then you can just start feeding it data, and it'll take that data and just start filling in the address range. So if I said take a tiny little corner in the lower right as my start and end to find that, and I send it 100 pixels, it's just going to start slamming that color data into that location. So what I want to do here is I want to say, well, I want to go 0, 0 as my start. So my X and Y are 0, 0. Then the X to the right of the screen ends at 479, and the Y at the bottom of the screen ends at 319. So that's my 480 by 320. And I say set that as my address window. So that's what I'm going to work within. And the set address window looks like this. Again, I'll have this posted. You can go back through this and see if it makes sense or critique it. I'm sure I probably need to do some documenting in it, but I'll post it as it is for now. But this is just doing more of those write commands. I write a command called 2A, which is a column address set. And then there's a 2B, which is a row address set. And then there's I want to actually write out data now, start the stream basically of stuff. And it seems like for some of these interface chips, you're supposed to write some dummy bytes. I've toggled that back and forth with and without it. I guess currently I have it in there. May or may not be necessary. But this is basically sending all of that parameter data of where's my start XY, where's my end XY, and tell it that I want to start streaming pixel data in for that specific address window. And so once I get done setting that address window, let me get back to my clear screen. It knows that I'm going to go, basically the entire screen is the range I want to work in. And then I just have a loop within a loop. And, if I'm writing a single byte, I should probably be in 8-bit accumulator mode. So I do that. And then I write out 2 bytes because it takes 2 bytes of data. But remember, I've only got an 8-bit, 8 wires going in. I can only send a byte at a time. So I send 1 byte, I send the other byte. Now this is easy because I'm just clearing to black. So this load 0 here is just simply saying this is black. And to be more precise, it is what I have to get sent in total is 0000. And so this is going to send the high 00, this is going to send the low 00. So send in 2 bytes in a row that tell it I want black, and that's going to be the first pixel. So it sees those 2 bytes and says, oh, black. First pixel turns black. And then I loop and loop and loop. I go through all the rows and columns and basically fill out the entire screen. So if I reset again right now and we watch the screen, you'll see that when I go to get to that clear point, it just simply runs from the top to the bottom, and it's clearing it from what it was to start to these blacks, and that's what this clear screen is doing. And at that point, it's initialized. So the screen, I've gone through all this initialization, I've cleared it at the end, and to me that is an initialized screen I can start working with. So then after I clear the screen, go back to my main assembly, I then say, well, let's put a test pattern out on there, and that's these 4 bars here, again, a red, green, blue, and white. And I could do whatever I want with the test pattern, but I just want to do something real quick. I wasn't going to take a lot of time with it right now. But on the test pattern, I put together a little procedure that looks like this. And basically I say I want a red rectangle, and I'm going to use that basically same, well, I'm going to use that same setting the address window, and I'm going to tell it, here's my start XY, end XY. So I want to go from 2020 to 46040. That's the first color bar. The next one is 2050 to 46070, etc. So that this is, I'm defining where those bars are at. I'm defining the color, and now I get to work with 16-bit color. So 565, this is all red. This is all green, this is all blue, this is all white, or whatever other combinations I want to come up with. And I store that into a variable called color. So I've got 5 variables, start X, Y, end X, Y, and color. And then I say, well, go call this thing called draw rectangle that I put together. And that's very similar to the fill of the screen. And basically it just says, okay, go ahead and write out those 2 color bytes, send them to the screen. But in this case, it's saying that, if I go back to what I was trying to fill in, it's just for that rectangle. So instead of the entire screen, I'm going to go from 2110 to 46130, and I want to fill that in with white. And so then it runs through that subset of the screen and fills in things white, just like my clear screen did with the entire screen for black. But I called this ILI draw rectangle, and you just have to make sure these variables are filled in, call it, and it will process based on the values in those variables, which is a handy little routine. And I can make those for circles and lines and triangles and all the other things, but for now rectangles are the easiest for me, and so that's what I did. And that's all the test pattern is it goes through four sets of those and gives me these color bars that you see here. So then after that is the animated ship. And if I go over to here and I look at the animated ship, that would be another procedure which looks like that, and it relies on another routine called draw ship once. So that's where I started with, can I draw the ship once? And basically I need to go out, and instead of setting the entire screen as the window, again, remember I've got this set address window, or instead of setting it for a bar, a rectangle, I'm setting it for a 32 by 32 chunk. That's how big that sprite is. So go find a spot, and I start out with saying, well, somewhere in this variable there's a ship sprite X, and that's where I want to start basically drawing my ship. And so this goes through the logic of saying, okay, fill in the start X and Y, end X and Y, and make sure that's set as my address window. And then I've got just a loop, and the loop basically is going to go through here and draw out the pixel data, reading it from my ROM. So my ROM is over here, and the system sees this ship at E1000. So I just read through that ship data, and as I read through it, I write out the bytes. So I read in 1 byte of data, because my sprite is only a byte. It's 8 bits of color data per pixel. But now I've got a problem. I've got 16 bits I need to fill in. And so I just did this. This is not obviously color mapping. So I said no color mapping. I just write that same data both to the high and low byte. In other words, if it was all red in my original, it would have been 111 followed by 5 zeros. So all 3 reds would be on. But then when it comes into this new, I'm gonna copy that both to high byte and low byte. So I'm gonna get my reds, but I'm also gonna get something on the bottom, some greens tied into that. So it's not gonna be red. It's gonna be a red plus green combination. So colors are out of whack, but this is where I would maybe call a routine that does some expanding of 8-bit to 16-bit color by sliding the right bits to a higher order. Slide the reds further to the left, slide the greens to the left, and then move the blues to the appropriate spot. But I didn't want to do that right now because it really wasn't important yet. But this draws a single ship, and so then this one that says animate it basically just goes through a loop. And I've got an animation loop, so I can come in here and I can say, well, I want to start out the first ship at 0, 180. So 0, so far left column down to 180. And then this is where I say draw the ship. And then the rest of this really is just tracking, okay, now move over a little bit, draw it again. And then move over a little bit, draw it again. Now the nice thing about this, and I did this on purpose when I built this sprite, again, if you squint, maybe you can see the ship here, but zeros are black, and I can see that the first 3 columns are black. So as long as I move 3 or fewer columns at a time, as it draws the new one, it's going to erase the old one, if that makes sense. These three columns of black will just simply erase whatever the trail or the tail of it is as it moves. So that's pretty handy, and I did that on purpose for that, so I could move it 1, 2, or 3 pixels at a time. And then over here, that's what I'm doing, is I'm just saying, okay, let's go ahead and just slide this to the right by 3 pixels, draw the next one, slide it, draw it, slide it, draw it, and I just kind of keep all that going. And really, that's just this chunk of code. And then at the very end, the very last one, I don't push it off the screen entirely. I stop it short of going off the screen, and then I just draw a black rectangle on top of the last rendering of this sprite. So this was just quick and easy. I'm sure this can completely be improved, but that gives me my little sprite moving across. But the idea that I'm trying to get across is all of this is just pixel by pixel manipulation. It's very similar to my VGA card, except for I don't have direct access to the memory. I have to go through these command and data sequences to update that. So to me, that means it's slower, and it is, I think. I don't know, I'll have to do some performance testing later as I get time, but, like if I reset this right now, I got to keep in mind that this little ship that's going to fly across here is going twice as far as it does on my VGA, and it still runs at a pretty good clip. I'm moving 3 pixels at a time, and again, it's probably not easy to see on the camera, but when I look at it, it's fairly smooth. I mean, I wouldn't complain about it. Now, obviously, that full screen fill takes a while, but once you're just doing little chunks of the screen, that's not bad at all. So let's see, we've got the init, reset, write, command, write data, pulse the write signal, procedure to draw a single pixel. And so here I've got this procedure. I give it a start and an end. Again, set a window, and then just simply draw in that window that 1 pixel. So that's simple. Clear screen, test pattern, draw a rectangle, animated ship, draw ship once. I do have another one. I'm not using this one yet, but it's instead of doing 1 byte write at a time, I've got a routine that lets me take 2 bytes or a word and deal with it as a word at a time. I just didn't find that I needed that quite yet. And then set address window. So I walked through all of those to kind of give you the high level feel for this. So I think, that's enough to get you up and running, enough to get me up and running with this. I need to go back and read this data sheet top to bottom at this point. I've barely even skimmed it, but that's what I need to do is kind of read through this and see, well, what else am I missing? What else should I be paying attention to that I could do that I should be taking advantage of? Maybe better understand some of those settings on the initialization, see if any of those I want to change. But, it's a lot of stuff here that maybe right now isn't so critical for me. Because a lot of that, I just have to plug in my data lines and send the right control signals. Much of those initialization values I got off of another sample project from the vendor, from this DIYables, and that all made it pretty quick. And I didn't see anything down here saying tested hardware of a WDC65265. So definitely not on there fully supported, but that doesn't mean we can't make it supported by building a little code to go with it. So I don't know if I'll end up keeping this. It seems like this is going to be quite workable. I think the biggest thing I need to do right now is just get font support for it, character support. And it'll be similar to what I'm doing. As a reminder, I've got all that character data in my ROM for a 5x7 font that I built. So when I go to my ROM data up higher, I'll just go to the top. I've got character data for the full ASCII table. This is 5x7. I think if I'm going to use it with the LCD, I'm going to package it differently and not have it in this 8x8 space. I'll make it just a stream of 5x7 data. But that's something I need to implement is font support. But if I got font support and I got cursor tracking, things like that built in, I'll be able to do graphics. I suppose the other thing would be to load just a full bitmap, but that really is no different than what I did with loading up that ship sprite. So all of that I think is going to be pretty easy to do. So with that, maybe I do, when I build my next board, figure out how this should mount on there. Maybe I put a header, a set of headers there that this can just fall onto, because it's intended to be a hat on top of an Arduino. And so if I made an Arduino type of header, physical header, this could drop onto it and be part of my board. And then if I have that working well and consistently, there's probably not a big reason for this LCD here, and I might just scrap this one, because everything I do on here I could obviously easily do on there and have more space. And I can always go with a bigger font too if I want. I don't know. What are your thoughts? Do you like the 2-line LCD? Do you like the the much higher resolution screen over here? Do you like the VGA? I don't know. And maybe it doesn't hurt to have all three in a board, but I think this LCD is what I'm leaning towards getting rid of. This one I'm probably going to build onto my WDC single board computer. And then this circuit I'm going to cut in half size-wise and probably include that on my single board computer. So I'll probably have a VGA circuit, plus I'll have this, and that way I can use whichever one I want to use. And it might be for more intensive things. If I want to try to get a game running or something, I'll use the VGA circuit. And if it's more show me status, tell me what's going on, communicate general messages, I'll use this TFT screen. And again, through all of this, I'm running the 10 megahertz oscillator, and the system is doing great. So I've got no complaints at this point, and we'll kind of keep building out some of this assembly code work. So another video that turned into a longer video than I probably would have guessed it was going to be up front, but hopefully if you are thinking about implementing one of these screens without its own microcontroller, just a raw screen with this ILI9486 interface or something similar to that, this gives you an idea of what does it take to do that from a microcontroller like this 265.